Mid-surfacing is another useful tool for shell modelling, and this allows us to extract a surface body that is midway between the existing faces of a pre-existing solid body. And we can do that in two different ways. There's a manual and automatic approach. But if we look at the geometry on the right hand side, this solid body, we can see this pipe which has a thickness, and we can create surface bodies based on the inner and outer surfaces in order to create a new surface body. So that can then be a simpler way of representing the original pipe section without the detail of the thickness of the pipe being explicitly modelled. Okay, so there are two different ways of defining the mid-surfacing approach. Either a manual approach, which operates only on user-specified face pairs, or we can apply an automatic approach where it tries to automatically define the face pairs to be used for the mid-surfacing. Now, when we create a mid-surface from Tools and Mid-Surface, we will see some detail options appear on the bottom left-hand side of the Design Modeler screen, and this allows us to edit some of the tolerances and also select face pairs where needed, depending on the selection method in question. We'll see some of that in the following slides. So here we can see the manual approach firstly. So what we do is we select the mid-surfacing option and set the selection method to manual. We then progress through the model, selecting the pairs of faces, one pair at a time, to be used in order for definition for mid-surfacing. The order of selection determines the normal direction, so you have to be careful in terms of the order in which you select the faces for mid-surfacing. So the first surface that's picked is in purple, as shown in the example at the bottom of the screen here, and the subsequent second face that's chosen for that face pair is shown in pink here. So we can see a set here of purple and pink faces, and once we finalize the selection of the pairs for mid-surfacing, their display is shown in dark and light blue colours as shown on the right hand side of the screen. It's possible that we can select multiple face pairs for a single operation, but they must be selected as opposing pairs. So we can see on the right hand side here the order of selection that's needed in order to correctly define the mid-surfacing. The correct order can be as shown in the image on the right hand side, and adjacent pairs will be grouped together if they are within or fall within the thickness tolerance, and this is shown at the bottom of the screen here. And we can edit the tolerances associated with the details of the mid-surfacing as shown in the fields of the details view for the mid-surfacing operation. These can be seen in the bottom right hand side of this slide. We can also opt for an automatic selection method for the mid-surfacing pairs, and that brings some additional options or preferences for creation of the mid-surface. It gives us an option to search for bodies, to limit the search to visible bodies, selected bodies, or have all of the bodies included for mid-surfacing, and it also allows us definition of minimum and maximum threshold sets for the search range for the face pairs as well. There are some options for trimming which are useful, and also there is an option to preserve bodies, which will allow you to preserve the pre-existing solid from which the mid-surface body was created. So when the search is complete and we've found all of the pairs that we need in order to create the mid-surface correctly using the automatic selection method for mid-surfacing, the mid-surface creation can then be generated by hitting F5 or clicking the generate button, and as we can see on the bottom right hand side of the screen, we can go from this set of face pairs as shown here after successful selection of the face pairs into the single surface body as shown on the right hand side.